Hey there, my name is Aiden Pelly. After our previous video, we talked about how a neural network works, all the theory behind it, and essentially what it does and how it works behind the scenes. Now we're going to be going over an actual example and demonstration of what a neural network does. Using an example that we talked about previously, we are going to take an input set of all these different images that we are going to read into our neural network. We are going to train it with it, and it's going to try and then guess what the image is of. For example, for ours, we're going to give it a bunch of images of t-shirts and sweaters and pants and socks and shoes, etc. And it's going to try and guess which one it is. And then afterwards, with our test data, it's going to try and take the test, and it's going to try and predict what the image is, essentially. So here is all the code that's necessary to do it with our lovely Google Code Lab, which allows us to run Python and TensorFlow in our browser on Google computers, which is great because I don't have the technology or the processing power in order to run TensorFlow myself. And then we're going to be using the TensorFlow AI API in order to actually build our machine and go from there. So first step is going to be setting our TensorFlow version, and then importing TensorFlow, the API, and then inside that API we're going to need Keras, which essentially includes all of our data sets. And then we use NumPy, which is just the math Python, and matplotlib, which is for graphs. So first step, run all this, make sure that everything works, and once that finishes, so we set the major version of TensorFlow 2.x, and once this is all done, there we go, everything has been imported perfectly. Took a little while on the TensorFlow since it's a giant machine learning API. Now this is going to be our data set of essentially fashion. Like I said, clothing, essentially shoes, socks, pants, shirts, whatever. That's going to be from Keras, which contains all of our free data sets that we can use because, yay, the internet is awesome that way. And then we're going to be splitting it into, oh, I misspelled that, testing and training data with our train images and our test images and our labels, etc. So once we run this, it just loads the data, downloads everything here. As you can see, we got our 29,000, etc. pieces, etc., etc., etc. Now that we have all that images, now we're going to look at the shape of the data. We talked about shape in our last set of videos. Essentially, it is the array, the size of the array, etc. So in this case, it's a single dimension array where each one is going to have, so essentially we have 60,000 different images where each one is going to be a 28 by 28 image, essentially, 28 by 28 pixels, which is like, what, 600-ish pixels in total, something like that, per one of the 60,000 images. Now, if we were to look at a single pixel right here, say 0, 23, 23, so the first image in our set, and then the 24th pixel by the 24th pixel, we get a value of 194. This is a value between 0 and 255, which represents the light level of the pixel. We are going to be working with grayscale this time simply because it's easier and it gives a very good idea. Now, if we were to look at the first 10 training labels, right, these are essentially what we're looking for our outputs. These are examples of them. So we have our class names, right? We have t-shirt, top, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag, ankle boot. The idea is that each one of these is going to be some value 0 through 9. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And the closer any result is to one of those integers is going to be its guess. So if we get 4.2, we're going to guess that's going to 0, 1, 2, 3, 4. It's probably a coat, essentially. So now we're just going to run that real quick, make sure that everything's loaded. Yep. All right, so we have PLT, which is going to be our plotlib, and we are going to draw a figure, and we are going to give an example of the shirt. So for example, if we're taking our second train image, which we said right here is 0, t-shirt slash top, as we can see right here, this is going to be the example of the image that the thing is going to be reading. And we can see that the actual image from the Keras data set, if we remove this, is a color shirt, but we don't need to worry about that because our data is just going to be using the lack of color like this. So this is an example of a shirt. Our AI is going to use data like this in order to predict shirts and other things. Here we are just normalizing our data In the past, in our previous video, I talked a little bit about normalization algorithms that will take very large values and convert them to something between 0 and 1. We luckily don't need anything like that because it's super straightforward, 0 to 255, just divide by 255, right? So that now our data is normalized. And now we're going to come over to here where we are building our model. So we're going to be doing a dense layer where every node from the input layer is connected to every node in the hidden layer, and then every node in the hidden layer is connected to every node in the output layer, where everything's connected, essentially. That's what it means by dense. Sparse would be if only some were connected. And then we're going to flatten the layers, so we know that the shape is going to be 28 by 28 pixels. And then this is our activation. So this is going to essentially take that data. It's essentially a normalization algorithm like I talked about in the past, but this will be working for our hidden layers and our output layers, where it takes those crazy large or small values and then it makes them within the size that we're looking for, 0 to 1. Or in this case, I guess 0 to 9, for being honest. So we're going to run this, and this builds our model. Now we're going to compile our model. This is what's going to actually load all the important algorithms. Like I said before, we need a loss algorithm that determines how wrong it is. In this case, it's going to be the sparse categorical cross entropy. I wouldn't worry about these too much. We don't need to know the math behind them right now. And then we have our optimizer algorithm called Atom, which is always fun. Same kind of thing. This is what's going to be optimizing our model. And then the metric that we're looking for the most is accuracy. How close was it to the correct answer? All right, so our model is now built, and now we are going to train it or fit it using our trained images, our trained labels. Now the trained images is going to be that giant list of images, such as this shirt, and our labels are going to essentially be these guys. Except in this case, it will be that array, right, of just a bunch of numbers between 0 and 9, which is the correct answer for each one. So, for example, with the shirt, we want it to be 0, and if it were, 9, and then if we wanted it to be the next one, we want it to be 0, etc., 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 right? Now, if we go back to where we were, epochs. Epochs is the amount of times we want it to iterate over the whole data set in order to train. So let's keep it fun. Let's do like 8 epochs, which means it's going to iterate through the entire set of data 8 times over, and when it fits. So this might take a little bit while of time to run. As you can see, we got a very nice loading bar right here. First epoch is done with an 82% accuracy overall. Not bad. 86 on the second. 87 on the third, etc., etc., etc. Now, something we need to keep in mind when we are running these kind of algorithms is that there is such thing as overfitting your training model. That means that you take whatever data you were given, right, and you ran it through so many times that while it's really, really good at predicting the training data that you gave it, it's not capable of predicting on a good level for anything else. So what you can do is you can play around with the number of epochs in order to increase or decrease the training accuracy and make it more general or specific as far as our testing data afterwards. So once this finishes, almost there, just need to let it finish running. We're looking at an overall accuracy by the end of 90.5%, which is pretty good. Now we just need to let that finish running. We're just passing all of our data, having a wonderful time just sitting, waiting for loading, because it is a blast. 3 milliseconds per step isn't bad. 6 seconds, 5 seconds overall, not the worst. Now, there we go, finally. I was waiting for that. I was a little worried, actually. Now we're going to try and test it. We're evaluating against the test images and the test labels with verbose, and this will be our test accuracy at the end, and we're using our test loss. So overall, we have a test accuracy of 80%, which is pretty good. Now we are going to pop this down. Let's try a different epoch, just to see what happens, essentially. See the different values. So if we go 1 epoch right here, it means it's only going to run through the entire thing 1 time. And this time we actually got a 90% accuracy, which was pretty good. If we were to run this, we get 88.169, which again, still really good. So didn't really change between those two too much. I could change it to like 10 or something, and we'll see what happens. Now let's move on. We are going to start doing our predictions. So now that we have our overall accuracy, we're going to go back to our model, and we're going to use that test data, and we're going to predict the outputs. So we just created our array. So if we look at our first one, this is going to be a giant list of the predictions for the first stage. Now, we don't really need to worry about these numbers super much. This is just an example of the first one of all the different values that we got. So if we go to here, this will actually show you what it is. So the overall prediction after using the entire 600 or whatever, the actual answer it came up with is 9 for first position, for our first prediction. And if we run this, we'll see that the actual answer was 9. So in this case, it was correct, which is awesome. And that was for number 0. Now here we have some code that'll let you actually input and output and test that data that we talked about before. So it's starting by getting a number, which it picks, and then if it's a digit between 0 and 1,000, return the value, and then we are going to go through and predict, and then we are going to show an example of it. So if we were to use 0, which was the one from before, we'll see that we got a shoe out, which is the correct answer for that one. And then we can run it again. All right, and let's say we do 23. I'll run through, and this is the example of the shoe that I was trying to do with the prediction. Yeah, so that's essentially how it works. You input the value, and then it tries to predict if that was the correct value or not. And that is all I have for you today. This is your super basic intro to TensorFlow and a neural network, an iterative neural network, pretty much as straightforward as possible as far as this technology goes. Thank you for watching.